Hi, it's Cindy Schwartz again from Vassar College. Now it's your turn to try to solve a problem involving non-uniform circular motion. So once again, we have a toy car going around a circular track. This time, the radius of the track is 0.6 meters. The car starts from rest and accelerates along the track with an acceleration of 0.4 meters per second squared. Our goal again is going to be to find the angle between the velocity vector of the car and its acceleration vector at point A, which, as we can see, is halfway around the circle. So the first thing you're going to do here is pause and see if you can find the relationship between S, R, and the angle. Okay, so hopefully you remembered the formula that relates arc length and radius and angle. S is equal to R theta. And again, theta has to be in radians. And you should have gotten that theta was equal to pi. Now we can go and use some other equations to find the velocity at point A. So why don't you pause and see if you can figure out what formulas you're going to need to use to find the velocity, linear velocity, at point A. So hopefully you recalled that equation, and if you calculated things correctly, you should get a final velocity squared of 1.5. So the next step is going to be to find the acceleration, and we have to remember that we have two different kinds of acceleration to deal with. So we're going to go on to the next page, but before you do, pause and think about what kinds of equations you're going to use to calculate the two components of the acceleration at point A. Okay, so hopefully you got those results for the centripetal and the tangential acceleration. And now we put them together to make the resultant vector. And we know that the resultant vector points sort of something like this. And this is the angle theta that you want. So why don't you pause and figure out how to calculate theta. So I got theta is inverse tangent of 2.5 over 0.4, and that gave me a theta of almost 81 degrees, 80.9 degrees. Okay, so if you had any trouble with this particular problem, you should probably go back and review some of the trig and make sure you understand why that angle theta is indeed the angle between the velocity vector and the total acceleration, which we can mark as here. Hope you had fun.